All right, last up in our algebra review, we've got section A7, quadratic equations. I'll just remind you very quickly what a quadratic equation is. It's an equation of the following form: ax squared plus bx plus c, so a degree 2 polynomial, equals 0. Or any other equation that can be rearranged to be written in this form. There's two primary ways of solving these, but before I get into those, let's just point out the very easy cases. Very easy cases. One would be if b is 0. So if b is 0. So for example, something like 3x squared minus 27 equals 0. And this is a quadratic equation where a is 3, b is 0, and c is minus 27. And the reason this is easy to solve is because all you have to do is isolate x. All right, just go ahead and isolate x. Well, okay, 3x squared, let's add 27 to both sides, equals 27. So this means divide both sides by 3. X squared is 9. And that, of course, means x is square root both sides. And it's not just x is plus 3, there's two different roots. X is plus or minus 3. Right, both plus 3 and minus 3, when you square them, you get 9. So, two solutions there. So b is 0, it's pretty easy to solve these. And similarly, if c is 0. Alright, so let's just go something easy. How about like x squared plus 2x equals 0. Why is this case easy? Well, because all I have to do is factor out an x. I can always just factor out an x in this case, so this gives me x times x plus 2 equals 0. And in this case, you'll recall this property of real numbers we had. If the product of two numbers is 0, then at least one of those numbers must be 0 as well. Right? So either x is 0 or x plus 2 is 0. And I'm running out of space here, but this means either x is 0, there's one solution, or x plus 2 is 0. And if x plus 2 is 0, that means x is minus 2, right? Isolating x again. So both of those are the two easy cases. If you have a quadratic equation where b or c is 0, then you're in pretty good shape. But in general, the other two ways for solving these are either factoring or the quadratic equation. Alright, so I've got this quadratic equation, 2x squared minus x minus 3, so a is 2, b is minus 1, c is minus 3. And I'm going to attempt to solve this by factoring. So what I want to do is factor this polynomial, this quadratic polynomial on the left here, this degree 2 polynomial. And this is one of the harder cases. I have to sort of go by trial and error here. The only way I'm going to get a 2x squared is if I've got 2x times x. Okay, and then I need two numbers here that multiply together to give minus 3. But when I multiply them by 2x and x, they're going to add together to give minus 1. I think what I want here is, let's go plus 1 minus 3. That should work, right? That'll give me 2x minus 3x will give me minus x in the middle if we expand it out. So yeah, this definitely factors like this. And that's all there is to it. Once you've factored your quadratic equation, you have the solution staring you in the face. I've got two numbers multiplying together to give 0. So either 2x minus 3 is 0, which means that, let's try and solve for x here. 2x is equal to 3, so x is 3 halves. Or x plus 1 is 0, which means x is minus 1. There's my two solutions. So solving a quadratic equation by factoring is really nice if you can factor. And you can't always factor, but let's just do one more example. Oh, by the way, these symbols that I use all over the place, my handwriting's not the best, but they're supposed to be little arrows like this. All they mean, they're a symbol in logic that just means that this line logically follows from the one before, or this line implies this one. Right, so I could have carried these through. 2x minus 3 equals 0 implies 2x equals 3, which implies x equals 1/2, or 3/2. Okay, so here's another one. 2m, I've just changed my variable name. 2m squared plus 7m equals 15. And I'm going through this example in particular because this doesn't look like a quadratic equation right now. Remember, quadratic equations are the form ax squared plus bx plus c equals 0. This equals 15. So what I have to do first is I have to put this in standard form. I need a 0 on the right, so I need to move this 15 over. This is 2m squared plus 7m minus 15 equals 0. Now this is in standard form. Now I can go ahead and factor. So keep this in mind. You always have to put stuff in standard form before you factor. You need something equals 0. So try and factor this. I will pause the video if you want, but this is pretty similar to last time. Now pause the video and try and factor this, but the only way you're going to get 2m squared again is if you have 2m times m. And now I'm looking for two numbers that multiply together to give minus 15. Not too many choices there, either 15 and 1 or 3 and 5. And I think what I want is plus 5 and minus 3. That'll give me 2m times 5 is 10m, minus 3m is 7m. So this does indeed factor like this. And then once again, this means 2m minus 3 equals 0, or m plus 5 has got to be 0. So solving this one really quickly, 2m equals 3, so m is 3/2, or m is minus 5. So in other words, solving these quadratic equations using this factoring technique is just another exercise in factoring that we've already talked about back in some of the earlier sections. So here's our second technique. If sometimes you can't factor your polynomials, sometimes they're just hard to factor and you don't want to bother, in comes the quadratic formula. And the quadratic formula says anytime I have a quadratic equation, ax squared plus bx equals, or ax squared plus bx plus c equals 0, then I have this solution. Then x is going to be minus b plus or minus the square root of b squared minus 4ac over 2a. And I'll say a couple of words about this. Notice one, I have plus or minus. So plus or minus means I'm going to have two solutions. As you're used to seeing, right, the last two examples we had two different solutions. Except in one particular case, actually two particular cases, maybe the square root is 0. And if I have 0 there, then plus or minus 0 means I actually only have one solution, because plussing 0 or minusing 0 is the same thing. The other possibility is this expression, b squared minus 4ac, that might be negative. And square roots of negative numbers don't make any sense at all. So in that case, if that turns out to be a negative square root, then we don't have any solutions. And yeah, let's just do an example. Solve 3x squared plus 2x minus 4 equals 0. So your first method of attack really should be to try and factor this. And if you try, you'll find that you can't. It's too hard to factor. It doesn't factor with nice integer values. And that's okay. Even if it did factor and you couldn't see how to factor it, that's okay. The quadratic formula will still work for you. Let's just make a few notes here. What is A? A is 3, B is 2, and C is minus 4, right? So my solutions are going to be, x is going to be minus b, so minus 2, plus or minus the square root of b squared, 2 squared, let's just write 2 squared, minus 4 times a, 4 times 3, times c, minus 4, all over 2 times 3. So that's minus 2 plus or minus the square root of 4 minus 4, this is plus 16 times 3, 16 times 3 is 48 over 6. Okay, so that's, we'll simplify this a little bit. That is minus 2, what do we have? Square root of 52 over 6 plus the square root of 52 over 6, or minus 2, remember this is plus or minus, so minus square root of 52 over 6. Full disclosure, this can be cleaned up a little bit if you really wanted to. Let's just take a look at one of these numbers. So for example, minus 2 plus square root of 52, that's the square root of 4 times what? 4 times 13 over 6. Right? So that's minus 2 plus. Now what I can do is I can write this as two different square roots. I can write this as square root of 4 times square root of 13, from what we know about square roots. And the square root of 4 is 2. So that's 2 times root 13 over 6. And if I factored out a 2, I would have 2 times minus 1 plus root 13 over 6. But 6 is 2 times 3, and I could cancel the 2's. So this number here, I can make this look a little bit prettier. This is minus 1 plus root 13 over 3. But as long as my math lab doesn't say something about give your answer in reduced form or something, this answer here would be totally fine. So is this one, but unless it says reduce your answer fully, you don't have to go all the way. So we'll just try one more. Z squared plus 6 equals 8z. Once again, I'll remind you that the quadratic formula only works if you're given your quadratic in standard form. Ax squared plus bx plus c equals 0. So I need the right hand side to be 0, so for starters, let's write this in standard form. Subtract 8z from both sides. And that should be the middle term because this is my coefficient b. So once again, let's just read off what they are. A is 1, b is minus 8, c is 6. And I could try to factor this. Go ahead and try and factor this, see what you get. But in the interest of using the quadratic formula, let's just go straight to it. This means z is going to be minus b, so minus 8. Positive 8, plus or minus the square root of b squared. 8 minus 8 squared is 64, minus 4 times a, 4 times 1, times c, 4 times 6. 4 times 6 is 24, all over 2 times a, 2 times 1. So this is 8 plus or minus the square root of 40 over 2. And both answers, by the way, if you want both answers, we're then looking at 8 plus root 40 over 2 and 8 minus root 40 over 2. And because these answers are so ugly, right, it's kind of an ugly answer, I know for a fact that you would not be able to factor this. Not nicely anyway, because your factors would look like z minus this expression. So I think that's enough. I think that's enough examples. I know you've done this stuff before, so I don't think we have to really sort of beat this to death. But again, I haven't done an example where the square root came out to be 0, so you only had one answer, but if that happened, you would obviously notice that. You would just have plus or minus 0, so the same answer either way. And we didn't do an answer where the square root came out to be negative, but if you do have a negative number here, that just means you have no real solutions. All right, thank you.